What other topics to discuss? What other things to discuss for now?
Uh, to you said this minus I and plus I order is there, right?
Mhm.
How do we exactly like come up with that?
Send me the order which you have been given. We'll talk. You write good notes or you write shitty notes?
I think this is understandable.
So you write very good notes then. Good.
Not too good, but like
But you scribble off everything which the teacher tells in class.
yeah, some
That's
of
what
it.
that's what I mean. That's very good notes. The teacher properly copies from the best books. I'm quite impressed actually. Fidji's teachers' levels have increased, man. And I mean that very seriously. I suppose on all top places will have good teachers. There's no escape about that. Yours is one of the top campuses, or it's what campus is it in Fiji? Second or third or fourth?
Well, barring the CM batch in Madhapur, this is the best.
Second batch then.
Yeah, second best. Yeah.
Nice, nice. And the Madhapur one will be getting like say 4 or 5, maybe 10 also in top 100 consistently, right?
Yeah, not 10, but like I
Four
think
or five
five.
consistently.
5, yeah. 4, 5.
Hmm. Same as the standard, huh? Go on, huh? Let's continue on with this. Which ones do you have issues on?
No,
Or
my
should I
general
give a
thought is,
general direct thing?
yeah, can you tell the general thing? How do we exactly like? Is it experimentally or like?
Obviously, it's experimental, but there's obviously going to be reasons also.
Hmm. Sir, I know about the NR3 and NH3 one though.
First
Like
off,
the
tell me, what do you know
bond
about
and
inductive effect?
inductive effect.
Hmm.
Well, it pretty much is when one polarized atom polarizes the other. Like suppose there's an electron negative atom, it pulls the electron density towards it, and then as a result, it pulls all the other ones around it, like nearby ones as well, even the further ones.
Okay,
Like like it polarizes the sigma bond
all of
of
that
all the
is
adjacent.
fine. Explain to me in simplest words and show me that you have understood.
It's pulling.
Show me you have understood doesn't mean I want you to use the same words you have heard. So it's like
It's like greedy, pretty much. Like
not bad, good. That is a good term. I like that one. So effectively,
it's like
when there
tax
is
collector collecting.
when there is something which is more electronegative, what does it mean for something to be more electronegative?
It wants electron density
What
near it.
electrons?
Sigma electrons.
What do you mean by that exactly? The bond pair of electrons, not necessarily
Ah,
sigma also. It can be pi also. So yes, we define it from sigma point of view, but it actually is going to be both. The pi is just a little bit less strongly attracted than the sigma because it is in a different angle, so it is going to be at more distance from the nucleus. So effectively, electronegativity is a tendency of the nucleus of a system to pull or attract any shared pair of electrons towards itself. So by
hmm.
creating that, by doing this, what happens is it is going to be literally creating an imbalance in the what to say
Molecule.
flow of electron density in the system.
Oh, huh.
So this imbalance which it is creating is going to be something which will be cascadingly felt. So if I'm going to be having a molecule like this, if there's a sudden center of greater electron density or electronegativity, let's say this part is more electronegative, this will literally tilt downward. That's the best way to imagine it. So you can think of it as the field or the gravity in that region to which the electrons are attracted towards is literally being bent downward. So what's happening is anything which is present over here is going to be feeling that effect to a greater extent. And the one which is present over here will feel that to a lesser extent. The one which is present over here will feel it to an even lesser extent.
Yeah.
And the one which is present over here, it doesn't feel it at all. Because by the time it reaches here, it's flattened out.
Yes.
You understand the idea here?
Yes.
So effectively speaking, the best way to imagine it is, imagine the electric field in a way, and the plane of the electric field of the molecule is dipping downwards at the location of greater electronegativity.
Like gravity. Yeah.
In a sense.
Yeah.
So if it is dipping downward, effectively you're going to be having a slope getting created. That slope is going to be most felt by the fellow who is closest.
So, yeah.
So what are these groups giving you? These groups are giving you pain centers.
Imbalance.
How much is it dipping over there in that field? How much of a deep dip is it creating? So the depth of the dip is going to be predominantly dependent on the desperation at that location.
Yeah.
You understand the idea here?
Yes, sir.
Okay, so now let's go for the order here. So, which ones do you understand? Which ones do you not understand?
So the FCl, VRI, I understand.
The iodine, bromine, fluorine, fluorine, you understand? Okay.
Yes, and then I think the C1CH and the third to last one and the second one.
This bunch is easy. Hydrogen is going to be your standard.
Yeah.
Okay. This is going to be an sp2 hybridized carbon.
Yes, that will be sp, so that's why less.
Yes.
And
And
more
then
electronegative.
we are having phenyl, which is sp2, but it is a ring.
So
effectively, there is more sp2 carbons there.
Oh, that's
compared to here. It's a longer chain now, so it can ring up. So sp2 ring. So it is slightly more. NH2.
Okay.
This is, pay attention here, this is sp3 nitrogen. So they're
Yeah.
telling you the sp3 nitrogen is more than the sp2 carbon, but less than the sp carbon. Do you see the key thing which you should notice over here? What is the key point you should remember over here? The key point you should remember here is in terms of electronegativity.
Nitrogen is between. sp3 nitrogen is between.
So sp3 nitrogen comes in between the sp hybridized carbon and
sp2 hybridized
carbon. This is something which will be very useful for you in a later dynamic. Now, when I say later dynamic, what do I mean here? I mean something like this. Let's say I am looking at an acid-base type of reaction between NH2 minus and say this hydrogen and say this hydrogen. What will happen is, in this first case here, this can react. It will produce an NH3 and it will end up producing this fellow for me. Why will it do this? Because this is
more electronegative
than that guy, than this C minus.
Yeah. Yes.
And this fellow can escape outside as a gas. So when it escapes outside as a gas, you will end up having forward direction happening. Actually, you do not understand that. Or do you understand that? Le Chatelier's principle you have done, is it?
Yes.
Then you understand this then when you are having a precipitation reaction or a gas formation reaction that will be moving in the forward direction. Why? Because the gas is being released, the product is escaping outside. So forward direction will forcibly happen.
Yeah.
This will not happen at all, because this is going to be in the opposite direction. So these kind of orders, when you get them, pay very close attention to them. When you pay very close attention to them, you will automatically start being able to, what to say, smell inconsistencies in them based on how many times your teacher has to give you the order. Because every order will be connected. If you understand the connections between each order, you can check and verify, has your teacher given you the correct same type of thing or not? Or is there inconsistencies in those orders over there? When you see
Yeah.
inconsistencies in those orders, you should be a little bit, accepting that different textbooks sometimes give different data. So give your teacher the benefit of the doubt there as well. Because I can see this order is good. And he has taken a good amount of pain to give this order for sure. And I'm not even kidding. Trust me on that. This is a very well put together order. Not bad at all. And then OH and then OR. So this is going to be, of course, sp3 oxygen. This is also sp3 oxygen.
Yes.
Normally, though, in this particular case here, I would prefer an OH and an OR being reversed slightly. All right. Slight reversal would be better because the R over there is usually going to be a plus I group.
Carbon. Oh,
It's a plus I group. Plus inductive.
sp3 carbon.
So if it is a plus inductive group, it is going to be donating to the oxygen rather than pulling away from the oxygen.
Yeah, that's what I was thinking.
Your teacher here has probably made the small assumption that the carbon is more electronegative than hydrogen. So it should be pulling more from the oxygen. But that is not the way it works. The logic which he probably went with over there is related to that. The carbon is more electronegative than hydrogen. So it should technically pull more. But it is not a carbon, it is an R. It is an alkyl group. Alkyl group's net effect is a plus I compared to a hydrogen. So when you define inductive effect and something as a plus I or a minus I group, what is the standard against which you are measuring it?
Hydrogen.
Hydrogen. So when I say, or when we talk about an alkyl group being a plus I group, an alkyl group is a plus I group means it donates more than hydrogen. Net effect is more donating than hydrogen. You understand the principle there?
Yes, sir. Yeah.
So I would prefer to switch these two, OR and OH. Otherwise, the order is fine till here. Next is COOH and then C double bond O. Now, in this particular case here, why is the order like this? Why is the COOH lesser than the C double bond O?
So maybe, so but it's not mentioned R, right? So
you tell me why. They are talking about inductor effect only. So he's giving you that this group as a group is weaker than keto. Why? In the keto here, I will be having this sp2 carbon attached to an sp2 oxygen directly present here, correct?
Yes, sir.
Okay. In the case of the carboxylic acid, what is going to be happening is we will be having this being an sp2 carbon only, and this will be an sp2 oxygen only, but there will be resonance with this bugger. Correct?
Yes.
That means carbon is technically now with an sp2 and sp3 in between oxygen.
Okay.
That is probably the argument with which your teacher has given that. But I will still not agree with this. I do not know about the data behind this here. I have another conflicting logic also associated with that. So I would not go with this particular part of the order with this much surety. You will not be getting that many questions comparing those. Avoid that game there. My gut feeling tells me that is not perfectly correct. That is another assumption which your teacher has probably made based on some questions he has seen. Now, let me give you a conflicting argument for the same thing. This carbon is going to be something which is going to be always having sp2 hybridization, definitely. Correct? Whether there is resonance or no resonance, it is an sp2 hybrid.
Correct. Yeah.
Same way, whether there is resonance or no resonance, it is always attached to an sp2 oxygen.
Yeah. Either that's or this side. Yeah.
And compared to this fellow, which is going to be mostly an alkyl, this is definitely electron withdrawing.
Yeah.
Right? So,
But you don't know it's alkyl, right?
yes, that's R means alkyl, no?
No, but it's not
There's nothing there. Nothing means it's a alkyl, no?
alkyl
Keto,
only.
right?
Okay, that's what I was thinking.
So I can still argue in this fashion here that there is going to be no effect over there, or the effect is going to be opposite. Are you trying to see what I'm trying to explain to you here? Never
Yes.
ever bank on data which is half cooked. Recognize sometimes that this is half cooked and why it is half cooked. In this case here, all these three are very tricky business. Do not compare them here. Do not add them. Club all of them together. Think of all of them as very similar to each other, but do not think of this being better than that in your brain. Aldehyde, keto, carboxylic acid are all similar. No more, no less. Because if you start associating unnecessary orders there will be places where it will go this way or that way. The reason why the order has been given this way is mostly because your teacher has seen more cases on the one direction in which he's basically given the cases. But these three are very close by in terms of their effects over there. I would not recommend memorizing any particular order among those three. I have seen, like, for some cases, the aldehyde being worse off than the ketone. Sometimes I have seen the ketone being, as he has mentioned over here, better off than the carboxylic acid. But usually, carboxylic acid will be better off than the ketone. I have seen those also. So avoid memorizing any specific order among those three there. I hope you understand what is the logic there. In the sense,
Yes, yeah.
I'm not saying he's wrong. I'm not saying I'm wrong. I'm right over here. I do not know. I do not know. So let us not, don't unnecessarily memorize things which are going to be controversial. Because when you introduce more controversy, that basically means you're introducing more assumption in your brain. And the more assumptions you have, the less fluidic, lesser freedom you can experience with respect to your thought. So you're making yourself more rigid if you have more assumptions. Anyway, coming back to the next part here. CCl3, CF3. Why is this the case?
Sir, F will pull the electrons from the carbon. So
effectively, you're going
carbon.
to be having normal electronegativity being the case here, correct?
Yeah.
The fluorine is more electronegative than the chlorine, so it is pulling more.
Yes.
Cool. Next, how about this?
Oh, yeah. Sorry. Yeah. Yes.
What's happening here?
This one I wasn't sure about.
This one is an SO3H, correct? SO3H,
Yes.
now it is like this.
Yeah.
Correct? The sulfur is going to be at least in a +5 oxidation state here. That makes it highly electron poor.
Yeah.
And highly electronegative. So its electronegativity ends up increasing here, and it is going to be doing a very good job of pulling. And more critically, it is attached to two sp2 oxygens. Very highly electronegative fellows. So you're familiar with how the sulfonic acid is extremely acidic, correct?
Yes, sir. Yeah.
Right? Because of the same reason, this particular oxygen is also electron deprived badly. So in this particular case, the sulfonic acid group is a fairly powerful electron withdrawing group. Cyano, for obvious reasons, C triple bond N. sp hybridized carbon attached to an sp nitrogen. Remember, sp nitrogen is more electronegative than an sp2 oxygen. So this is
Yes.
very powerful electronegative. NO2. All of these are the nitrogen fellows, standard nitrogen fellows. What is the problem with the NO2 here? NO2 is of course going to be what? Nitrogen with a +1, right?
Yeah.
So this is NO2. So of course it's nitrogen with +1. It is planar. Being planar has an advantage. The advantage is if there is water or some other solvent, it will stabilize this nitrogen +1 a little bit more, because the nitrogen can be surrounded by those water molecules a little bit more comfortably. So in this region and in this region, water molecules can approach it now. It will get more nicely stabilized if a solvent is available. Now, why is the NH3 plus better than the NR3 plus? That reason only. If I have an NR3 plus,
Repulsions between R groups.
yes, repulsions between R groups is going to be enormous, and the plus is something which is surrounded by fat fellows. Being surrounded by fat fellows, other solvent molecules which can stabilize the nitrogen cannot approach. So since they cannot approach, this is much worse off. Same
Or
goes. Yes.
the bond length will increase, right?
No, that and all doesn't really matter.
The bond length increases, then electron
No,
will
no, no, no,
deprive.
no. Stop for a second. Stop for a second. Stop thinking bullshit here. What does bond length have to do with shit here? Where did you come up with bond length crap here? What's your logic for bond length?
I said more repulsions are there, so
So, in this case here, who is the boss in those bonds?
nitrogen.
So, you really think the boss in those bonds is going to give a shit about longer bonds? Who is the one who will suffer from the longer bond?
These
Yes.
are alkyl groups.
Yes. So, is the nitrogen going to be affected by longer bonds in any way?
Slightly.
No. If there are longer bonds, it is beneficial for it. Right? That means the bond is going to be weaker. Which direction will the bond be weaker in? This nitrogen is one of the most electronegative. That's why it is highly minus I. Correct? So if it is highly minus I, where are those bonds going to be pretty much? They are in the goddamn vicinity of nitrogen only, those electron pairs. The other guys are like barely hanging on to each other and fighting with each other at the same time. You understand the situation there?
Yes, sir.
Nitrogen has nothing to play with in the bonds over there. It doesn't give a shit about those bonds. So what you are trying to explain there is a completely conflicting understanding. Never ever go in that direction. See, there are going to be some types of, when you are learning things for the first time, it's like you are now literally going through a forest. All right. What am I doing over here? I am a guide who is basically not even me. Your school teacher is your actual guide. Your school teacher is your actual guide who is trying to guide you through this forest. When I say guide, he also gives you, tools for you to survive in the forest. But your school teacher is a trekking guide who has to show off that he knows the forest very, 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 very well. So he has to take you to all the beautiful spots in the forest, which are going to be a pain in the ass to trek towards. You are going into the forest for the first time. Behave like a visitor for the first time. Stop trying to visit spots which are meant for professionals. In this particular case here, what you're asking is effectively something along those lines. And when you're trying to make up a logic, what you're trying to do is something which a professional should be doing. Someone who actually has walked this path and has made their own path, they can start doing that kind of a jump. Applying your intellect is only going to lead you down the wrong path here at this stage, because you do not have enough data. Applying your intellect here means behaving like a goddamn pro when you have no business behaving like a pro. Am I driving the point through here?
Yes, sir. Yeah.
So in this particular case here, stop. See, first learn the standard things first, because unfortunately there is no other way. In this case here, the true logic is not having to do anything with the bonds over there. The true logic has to do with how the nitrogen is stable and why is it unstable. The reason why it's unstable is because other fellows cannot approach it. These three fighting is like a pack of rabid dogs which are near a nitrogen and are fighting like crazy. The owner of the three dogs doesn't care, because the three dogs are surrounding the owner, but nobody else can approach that owner now. You understand the point over there? That is the real problem here. So the owner might be having 5 suitcases to carry and might need help, but nobody can go help.
Yeah.
Why? Because the rabid dogs around that owner are basically not allowing anybody else to approach. That is the true problem here. The nitrogen here is desperate for something to come and donate it electron density. It is having a positive charge here. It wants to get solvated and surrounded by molecules which are at least sharing their electron density with this guy. But nothing is allowed to approach this particular nitrogen here. Why? Because the 3 fat groups around it are making sure nothing can approach. That's the problem. You're clear here?
Yes, sir. Yeah.
Okay, now let's go for the last fellow there, NF3 plus. What's the issue there? These are fat groups with 3 lone pairs each, and they're also screwing also with the nitrogen.
Yeah.
So effectively, this is steroids of the previous case.
Yeah.
Now,
Yeah.
next, which parts do you still have issues in? Any
Uh,
further? Yes.
Sir, when you're checking strength of plus A and minus A of different compounds, I was like, we were given a priority list. Like you should follow that the distance should be greater than the number should be greater than the power of the group.
Again, avoid rules.
But it's working everywhere.
No, it's working in the questions you have seen.
Oh.
So, give me the rule. Let's see what your rule is stating actually.
Distance should be given more priority than number of groups should be given more priority than the strength of the group.
So, distance is more priority than number of groups. Number of
More
groups
priority than
more
strength.
priority than strength of each individual group.
Yes, sir.
That sounds like a reasonably good logic. And there will be very, very rare cases where this will fail. This is a very good set of logic. You can use this. But remember, there will always be boundary conditions.
Sir, but why is this correct? Like if you had like
What is the logic which we just talked about? Remember the explanation I gave you? The visualization which I told you about just a while back?
Yeah.
Imagine it in that sense. Things will become blunt. Right?
Wait a minute. It's kind of
No. Make it convincing for yourself. What does the rule basically tell you? If I have a deep depression right next to me, I'm going to feel it more.
Yeah.
Correct?
Oh, and if you have multiple number of small, okay. If you have a very big one, but then how do you compare the last one? The strength,
You think, I told you the visualization. I'm not going to be helping you in every tiny bit of the case. You have an intellect which you have an ego over, right? Think.
Some cases.
So the last one is you give priority to more number of deeper pits than one pit which is going to be slightly deeper.
But what about the distance?
Think. In this case, will distance be a factor? Should you consider distance? If distance is a factor, distance is the most important, na?
Yeah.
So in the case when you're comparing the second and third parameter, what should you do?
Oh, sorry. Yeah, correct. Yes.
Stupid shit, you bugger. I mean, you claim you understand mathematics properly, but you don't apply it in these cases.
Okay, understood. Yeah.
What am I talking about from mathematics now?
This has greater weightage. Like if this
What
increase,
concept am I talking about from mathematics here?
logarithm,
No,
exponential.
no.
No, oh,
I'm talking about partial differentiation.
I don't know.
Okay, you've learned differentiation.
Yes, sir.
So when you're having a function depending on two variables,
Hmm.
you want to study the dependence of the mathematical function on one of the variables. What do you
Yeah,
do?
that's what
You
I
keep
said.
the other guy a constant and you play with the first guy, right?
Yeah, that's what this is
That's
exponentially more.
basically what is called
That's
partial
what I meant.
differentiation.
Okay.
In this case, that's basically what we are doing over here. Effectively, when you want to play with the second and third variables and find which one is more important, you should keep the first variable a constant.
Yeah.
So you can compare two groups at equal distance from a particular location, which are slightly less depressing, less deeper than one group which is at same distance.
Yes, sir. Yeah.
You understand the idea here?
Yes, sir.